Number 5, what is the temperature of a given mass of a gas initially at 0 degrees Celsius and 9 atmosphere if the pressure is reduced to 3 atmosphere at constant volume? So the first thing, as always, is to list your parameters. So the first one we have here is, what is the temperature? So we are looking for T. And we don't know, is this T1 or T2? Now you read the question, and from the question you will harness which one is T1 or T2. What is the temperature of a given mass of a gas initially at, so initial temperature is this, so initial temperature is T1. So T1 is this, 0 degrees Celsius. Or we'll convert to Kelvin immediately. So add 273 to give us 273 Kelvin. Initially at this and this. So if initially is this, then T1 is this and P1 is also this. So P1 is 9 atmosphere. Now the question says, what is the temperature of a given mass of a gas initially at 0 degrees Celsius and 9 atmosphere if the pressure is reduced to 3 atmosphere at constant volume? So P2 from the question is 3 atmosphere. So we are asked to find T2. We are asked to find T2. But then you look at this and you wonder, but there is no gas law that actually has a direct correlation between P and T. Look at the question again. It says at constant volume. So constant volume means that V1 is equal to V2. So this involves volume, but the volume did not change. So you can, if for your own good, you can decide, okay, if I'm confused, let me assign any volume to it. But V1 will be equal to V2. And at the end of the day, V1 will still cancel V2. So it's as good as it's not there. But then there is a formula that involves all of them, and that is the general gas equation that combines both Charles and Boyle's law. And this is general gas equation, as we already know, P1 V1 over T1 equals to P2 V2 all over T2. Okay. So we're asked to find T2. So when we make T2 subject of the formula, we have P2 V2 T1, P2 V2 T1 all over P1 V1. So T2, since V2 is equals to V1, will cancel out. Is that clear? Because if this is, whatever this is, if this divide this, it's the same thing, it will give you 1. So we cancel it out. And we have P2 T1 all over P1. Alright, so we put in the parameters. So P1 here is 3 atmosphere times T1 273 all over P1 9. So T2 will give us, this will give us 91 Kelvin.